Hi Year 9, this is our fourth lesson for the topic of trigonometry. In this lesson we're going to look at angles of elevation and depression. So far we've learnt about labelling the sides of a right-angled triangle and about the trig ratios, sine, cosine and tangent. We've learnt how to find an unknown side, and last lesson we learnt how to find an unknown angle. Now there are two angles that are important in trigonometry, and they are the angles of elevation and depression. And they are both measured from where you are looking straight out at the horizon. So the angle of elevation is the angle between the horizontal looking up to the object. So it's this angle here. The angle of depression is the angle from where you're looking straight out down to the object. So it's this angle. So let's have a look at this example. Let's label the angle of elevation of A from B. So we'll put ourselves down here at point B and we'll look up to A. And so the angle is going to be between the horizontal and looking up to the object. So it's here. How about labeling the angle of depression of B from A? So we're positioned here and we're looking down at B. Now, a common mistake is to think that it's this angle here between the vertical and where you're looking down to the object, but it's not. Remember, it's from where you're looking straight out. So when you're doing the angle of depression, you need to construct an additional line. So here's our horizontal, and it's from where we're looking out down to the object. So it's this angle in here. Now here's a cool trick. The angle of depression and the angle of elevation are actually the same size. Can you see why that is? Do you remember what these angles are called? You might call them Z angles. More formally, they're called alternate angles. And alternate angles on parallel lines are equal. And these two lines are both horizontal, so they are parallel. So, angle of depression, angle of elevation are the same size. And that can be very useful to us. Now, many questions will provide a diagram, but sometimes you're going to need to draw a quick sketch. So in the next couple of examples, I'm going to show you how to do that. So here's our first example. Pedro is looking at the top of a tall tree. He measures the angle of elevation from the ground, so that's this angle here, up to the top of the tree as 52 degrees. If he is 12 meters from the base of the tree, how tall is the tree? Okay, let's get rid of these pictures, and there is our right angled triangle. So just fill it in. Got a right angle here, and we're ready to do some trig. We want to find the height of the tree, so that's here. Okay, opposite our right angle is our hypotenuse, and then locate the angle. Opposite the angle is the opposite side, and next to the angle is the adjacent side. So having a look at what we've got O and A. So, ka, toa, it's tan. So tan 52 is the opposite, which is x, over the adjacent, which is 12. We've got our equation. Let's take our 12 over the other side. So it becomes times by 12. And x will equal 12 times tan 52. Put it in the calculator and we get 15.4 meters. Here's example 2. George stands on top of a building and waves to his friend who is across the street sitting on a bench. He measures the angle of depression to be 62 degrees. Now remember, that's not this angle here. It's actually the angle from where he's looking straight out to where he's looking down. So we need to construct this horizontal line. If the building is 20 meters tall, how far away is his friend by line of sight? So that's this distance here. So let's put a pronumeral. Okay, remember what I showed you before, that the angle of depression is the same as the angle of elevation. So we can shift this 62 degrees down in here, and that puts the angle inside the triangle for us. Okay, let's get rid of some of these pictures. And there's our right angle triangle, and we're ready to do some trig. All right, so we have a right angle here. Opposite our right angle is our hypotenuse. Locate the angle. Opposite the angle is the opposite side, and next to the angle is the adjacent side. What have we got? Opposite and hypotenuse. So katoa, it is sine. Sine 62 is equal to, opposite is 20, and hypotenuse is x, so our pronumeral is on the bottom. Do you remember what to do? We switch sine 62 and x, and then into the calculator. 20 divided by sine 62 gives us 22.7 meters. Now, of course, she can also be asked to find an unknown angle. So let's have a look at this example. Kim is flying a kite. The string on the kite is 30 meters long. So let's write that in. It's here. And the kite is 11 meters horizontally from her hand. Now, what does that mean? Firstly, we're going to need a right-angled triangle, so let's construct that. 11 meters horizontally from her hand. Here's her hand. And horizontally to the kite, that's this distance here, 11 meters. What is the angle of elevation to the kite? So that's this angle. Okay, let's do some trig. Opposite our right angle is our hypotenuse. Locate the angle. This is the opposite side, and this is the adjacent side. We have A and H. So, ka, toa, it's cos. All right, let's have a look. Cos of the angle is the adjacent side over the hypotenuse. There is our equation. Bring the cos over the other side, it becomes inverse cos. And into the calculator we go shift cos 11 divided by 30. It doesn't ask us to do to the nearest minute or degree, so let's just do it to the nearest degree. Our answer is 68 degrees. Okay, here's our last example. Evelyn is in a boat out to sea and spies a lighthouse on top of a cliff. She knows the lighthouse is 14 meters tall and the cliff is 80 meters tall. She measures the angle of elevation to the top of the lighthouse as 42 degrees. How far out to sea is she? Okay, let's get rid of these pictures and do the trigonometry. Okay, so firstly we have a right angle here. Opposite the right angle is the hypotenuse, which we don't have. Here's our angle. Opposite that angle is the opposite side, and next to the angle is the adjacent side. So we've got O and A, which is tan. So tan 42 is going to be equal to 14 plus 80 divided by x. So we've got an extra step in this one. It's not particularly difficult. 14 and 80 is 94. And we've got a pronumeral on the bottom, so we're going to switch the x and the tan 42. So we've got 94 divided by tan 42, put it into the calculator, and Evelyn is 104 meters out to sea. Okay, that's it for this lesson. In our last lesson for trigonometry, we're going to look at bearings.